Hello, welcome all the participants to the today's session on working of PN Junction diode. This is Mahendra Nagrani, Assistant Professor, Department of Electronics and Telecommunication Engineering, CSMSS, Chhatrapati Shahu College of Engineering, Aurangabad. Learning outcomes. After watching this video, you will be able to define what is PN junction, discuss what are different types of biasing used in PN junction, demonstrate how current will flow in a PN junction when it is in forward bias and also when it is in reverse bias. So let's look into what is PN junction. PN junction is a semiconductor in which it is partially doped with p-type and other part is partially doped with n-type and forming a p-type region and n-type region. The p-type region, the holes are majority charge carriers which are positive charge, and in n-type region electrons are majority charge carriers which are negatively charged. So we get a region where there is positive charge and negative charge together, and that region is called as PN junction. So let's see what happens at PN junction. So at PN junction, P-type material is meeting with N-type material. So the electrons in N-type material will start merging with the holes in P-type material, forming a neutral region. So this neutral region will keep on increasing until no more electrons is capable to move towards the p-type region to merge with the holes, and this neutral region is called as depletion layer. So, PN junction is nothing but a semiconductor with p-type material and n-type material. In between p and n-type there is a depletion region. So, this is also an insulator. That means no charge will be moving freely because of this depletion region. Biasing. So biasing is a technique where the external power source is attached with PN junction to give external power supply. So there are two types of biasing, forward biasing and reverse biasing. So let's look into forward biasing. The forward biasing is a technique in which positive terminal is connected to the p-type region of PN junction and negative terminal of a power source is connected to the n-type region of the PN junction. So let's see what happens when this type of connection is done, that is at forward bias PN junction. So in forward bias PN junction, the positive charge from positive terminal will move towards the p-type region which is also positive charge, and negative charge from negative terminal of power source will move towards the n-type region which is also a negative charge. So the density of positive charge in p-type region will keep on increasing and the density of negative charge in n-type region will keep on increasing. So eventually this density will overcome the depletion region and will eradicate the depletion region. At this point it is called as breakdown, and the voltage required to for the breakdown it is called as breakdown voltage. At the breakdown voltage, the majority charge carriers will be free now to move from one place to another, and that's why the PN junction will start conducting electricity and becomes a conductor and will also follow Ohm's law. Reflection point. Now I want everyone to take pen and paper and note down what you think about when the polarity of the external power source is changed. And also think about why that will happen. So we will stop for some time so that everyone could note what they are thinking. Okay, now I think everyone has noted it down. So let's see what actually happens. So when we reverse the polarity, we get reverse bias PN junction. So in reverse bias PN junction, the negative terminal is connected to p-type region of PN junction and positive terminal is connected to n-type region of PN junction. So let's see what happens. The electrons, that is negative charge carrier, will move from negative terminal towards the p-type region, and the positive charge from external power source will move towards the n-type region. So what happens is the holes in p-type region which are positive charge will get attracted towards the negative charge which is at the connection, terminal connection, and same way the negative charge, that is electrons in n-type region, will get attracted towards the positive charge at the terminal connection, so that the gap between the holes and the electrons in semiconductor will keep on increasing. The size of depletion layer will increase, and it will go on increasing until it breaks down. This is called as breakdown point for reverse bias, and the voltage required for breaking down the depletion layer is called breakdown voltage. So at this point, suddenly the holes are, that is the charge, positive charge and the negative charge, are free to move from one place to another place, and there will be an exponential increase in the power, in the current flow in the PN junction. So this is about the forward bias PN junction and the reverse bias PN junction and the working of the PN junction. Thank you very much.